Hello, this is one of a series of short videos produced by XP Power in response to questions received by our applications team around the world. We hope you find them useful. Many electrical systems and machines include operating modes where a peak load is placed on the power supply. A typical situation would be a machine that includes a pump. The machine runs comfortably, drawing 200 watts from its power supply, but every 10 seconds it runs a 600 watt pump. A chart of the power required might look something like this. The obvious solution is simply to include an 800 watt power supply, but the system designer will have budgets for the bill of materials and also for the physical space available within the machine. In this video, we will look briefly at 3 ways to optimize the cost and physical size when selecting a power supply for a load with peak demands. Let's have a look at that chart again. We can see that the peak load lasts for 3 seconds and is turned off for 7 seconds. We can describe the on-off times as the duty cycle of the pump, where the on time is a proportion of the total cycle time. The duty cycle of the peak load is an important factor in the thermal response of the power supply, and in this example we can describe the peak load as having a duty cycle of 30%. The average power requirement is also a critical factor in selecting a cost-effective product. So here is the equation for that. In the example given, we have an average power of 380 watts, less than half of the peak power, which will be significant in the product selection. Our first option is to look for products with separate power ratings for convection cooling and forced air cooling. In a convection cooled application, the average power would be supported by the convection rating, and the peak power may be supported by the forced air rating if this is greater than the peak and after careful consideration of the duty cycle. An example power supply would be the PBL 500, which has a convection rating of 250 watts but will run at 500 watts with forced air. A second option would be to select a product specifically designed to cater for applications with high peak loads. The peak power rating would typically be 100% more than the average power rating, with the thermal design and overload protection all anticipating the peak power demand. An example would be the CMP 250. Which is designed to sustain a peak load of 500 watts for up to a minute. This has been designed to cope with motors and other electromechanical loads and is safety approved for both medical and industrial applications. Finally, for situations where small peak loads of 10 or 15% are anticipated, it is possible to exploit the margin provided in the specification between the output current rating and the lower level of the overload protection. Provided that the average power demand is kept below the output current rating, occasional peak power demands can be fulfilled while keeping the size and the cost of the power supply down. Here is a very useful example. The ECL series, with models between 5 and 30 watts. The overload protection starts at 120% of the output current rating in this family of products. In conclusion, this is a very brief introduction to the topic. For more detailed information, do explore the resources section of our website using the filter Peak Loads. Where appropriate, our product datasheets carry a table of locations where thermocouples should be attached to the power supply during testing to validate it for your peak load application. This is very important for products that do not have their own cooling fan. My name is Alan Hill, and I hope you found this video helpful.